Welcome back to 3-1 Gang Change the Conversation, a podcast where we talk about software engineering. We bring on experts in the field of tools and processes in these areas. And again, we're real pleased to have you back, Amit Talwar, the indestructible sword. How are you today?
Good. How about yourself, Bryan?
We're good. I love saying that, so you have to forgive me, So anyway, this is number 6. This is our 6th and last podcast together. Well, hopefully we'll do some more, but regarding Automotive SPICE or ASPICE. And we've talked about requirements. We've talked about change management. We've talked about bidirectional traceability. There's a whole bunch of other stuff in there. The last one was around change management and problem resolution. Today we're going to talk about something quite practical, I guess, is how to prepare for an ASPICE audit. So why don't you give us a little background about what we'll be talking about?
Yeah, perfect. Thanks, Bryan. So, I've worked with a lot of clients. My colleagues have worked with a lot of clients in automotive and suppliers. And one thing that suppliers tend to do is they try to prepare for an official audit by doing in-house assessments, whether they do that with their in-house process teams, whether they utilize a third party to come in and assess them. What we've seen one of our customers actually do is utilize Rational Engineering Lifecycle Manager or RELM to actually drive an assessment. And
so this is an IBM tool then. So this is
yeah.
Okay, great.
So RELM is we've talked about our continuous engineering platform. It's an integrated set of tools. RELM is also a part of that. RELM is an application that it actually indexes all the data across all the tools. So depending on what the engineering artifacts are, it's indexing all that data. It's indexing all the relationships between those data, those artifacts. So it's indexing the relationship between requirements and tests and requirements and work items and architectural elements. And then what that gives you the ability to do is then create compliance views to say, I want to look at, when an assessment comes in, typically what they're doing is they're assessing some type of feature. They'll look at a feature and say, show me that you've actually developed that feature, you've broken it down, the requirements, show me that you've actually implemented it, show me that this was actually, you tested it, that you have coverage for those requirements, that the actual test passed, those results are you showing a passing result on those tests. And so to be able to do that, RELM gives you that ability to create these type of views to help drive these type of assessments because it knows all those engineering artifacts, it knows the relationships between them, so you can create these type of presentations where you can say, I'm going to choose a feature and I'm going to drive down and look at all the requirements that are associated with that feature, all the breakdown of those requirements from maybe system to software to subsystem, sub-software, and then
change requests. Yeah, change requests are in there too. Models?
Yeah, exactly. Models can be in there also. Exactly.
I mean, that's pretty much the gamut right there.
Exactly. And so what we're going to show today is just give you an overview of what RELM is and how I'll show you a sample of what one of our clients, our suppliers, one of these Tier 1 suppliers actually created with RELM, and we'll actually see it in the demonstration.
Okay, so just to be real clear, if you consider RELM to be the hub of a wheel, it's pulling data from the other rational tools that we've talked about in this podcast series and allows you to demonstrate to the auditors, whether they're internal or external, how you've met the standards of ASPICE.
Exactly. Making sure that you've established that bidirectional traceability. Right.
Okay.
And that you have your passing results on those requirements that you tested.
And I know this is our ASPICE series, but I would assume this could be done for other compliance or regulatory compliance mandates as well, right? So, I mean, ASPICE is one of many.
ASPICE is one of many, whether it's CMMI, whether it's IEC 51208, right? Any of the functional safety standards that could be out there. They're all going to ask about bidirectional traceability.
Yeah.
DO 178B and C, right? So you can utilize RELM to help drive those compliance reports.
Okay. And real quick, since we're going to talk, we're using this time to talk a little bit about RELM itself. Where else is RELM useful? I mean, there must be quite a few use cases. This is one of them. This is one of them. But what are the other one or two ways that RELM adds value to an engineering organization?
Yeah, so it really gives the ability for your engineering teams to unite, because it's the central area where you can look across all your engineering artifacts, regardless of what repository they are, and you can look at it for just querying, right? You want to find out everything that's related to some type of, say in an example I'm going to show you, I'm going to look at anything that's related to autonomous braking. All right, so we can do a query, like look at all the requirements, all the change requests, all the test cases associated to it. So it gives you the ability to, instead of trying to figure out where the data is, I can look for the data just by a simple query, like a Google search.
Nice. Okay, so it's like an internal Google search, so to speak, regarding a particular data. Okay, that's a good way to think about it.
You can also utilize it to organize and create these type of what we call views, right? These are pre-created views for you to be able to show some type of, whether it's traceability, whether it's time-based reports, if it's
progress metrics.
Time-based views, some table-based views, any type of cost-based views, methodology support, right? These are all areas that you could utilize.
Okay. Well,
it gives us that ability, and it also gives us the ability, one thing that we didn't cover is we talked about impact analysis. We've talked about it a couple times in these sessions. Well, RELM is the area where you actually can drop. So if you want to say, you know what, we have a requirement that needs a change, we can run an impact analysis on the requirement and see what is all the other information around it, right? Okay. What else is that linked to, upstream, downstream, that we might need to take into consideration before we actually make that change.
That's interesting. Okay. Well, good. Thanks for providing that overview. I think you've got a demo queued up for us and maybe a slide or two, so let's have a look.
Yep.
So, Amit, before we get into how organizations can successfully prepare for an ASPICE audit, you're going to walk us a little bit through Rational's Engineering Lifecycle Manager tool, what it is, and how it can help. Yeah?
Exactly.
All right.
So people ask, what is RELM? And if we go back and look at our platform of tools, it's really based on this idea of linked data, right? Regardless of where the data is, what repository it is, we want the ability to be able to link it. So it's across different federated repositories. We utilize a standard called OSLC, which stands for Open Services for Lifecycle Collaboration. And that really is just a standard of how you can link data across tools and how the communication needs to happen, that communication protocol. So
real quick, we were talking earlier about how it can pull information from the other Rational tools, though with OSLC, then it can really be linked to data sources outside the Rational tool set as well. Is that fair to say?
It can. If a data source has the capability to follow that OSLC standard, utilizing track resource sets, RELM can utilize it as a data source.
All right, excellent.
So when we talked about knowing that, RELM gives us that ability to index all that data, index the relationships, and then you can do things with it like graphically present traceability views.
Okay. And that was a piece that we talked about. It's really one of the differentiators here is that it's a graphical representation, which makes it really easy to quickly see the relationships between data sets, and then you can
also understand
drill into them. Yeah. Okay. Got it.
So we look at RELM, right? We talked about utilizing our COM, our continuous engineering tools, whether it's DNG, Rhapsody, RTC, RQM, whether test cases, if it's work items, if it's actually models, or even requirements. We understand all that data is linked. We understand what each data artifact is, and RELM is actually indexing all of that, collecting all of that information, so you can actually do things with it, like do impact analysis search on that data, or create these predefined views. And so some examples of these type of views that you can be delivered is we can look at traceability views, which is really important for ASPICE, but there's other views, right? If you want to understand impact analysis, right, we can create those type of impact analysis views, so we can look at, we're going to propose a change, or we understand that we need to change something, or a defect was found, right? Where else is that defect could be? Is there something else that we need to consider when we have to try to resolve that defect? Right, so we can look at those type of impact analysis. We can also do methodology support, as we talked about.
Mm-hmm.
So looking at, we look at an example of this, and we'll see some of this in a demonstration, right? It can anything from driving it from the actual physical architecture, right, and how that architecture is actually decomposed into different elements of that architecture, into, the actual use cases that define that system, and how that's related to the requirements and the test cases that are related to that. And this is that example of doing a dynamic impact analysis, right?
Mm-hmm.
We start with a task. What else is that task related to? Are there other requirements or test cases associated there,
Mm-hmm.
right? And so we can understand that type of view. And this is actually an example of a ASPICE compliance view that one of our customers actually presented on in one of our conferences.
Mm-hmm.
They actually utilized RELM to drive their ASPICE assessment. And one of the comments that they found out from the assessor afterwards, the assessor didn't believe that this was actually live data, right? So they actually, so the assessor comes in and he says, well, I want you to show me how this feature is actually, how you've actually implemented that. And so they went straight to RELM. They said, well, here's our view. Let's pick on that feature. They picked on that feature, and next thing popped up was, all right, here's all the system requirements that related to that feature. There's all the software requirements that related based off of it. Here's a link to the architecture elements that we have, right, and the tests and the execution records and the results of those, right?
Nice.
So those are simple things that, was quite easy for them to dive into and say, yep, we've actually managed that, right? And this is live data.
That's
and so
awesome.
We'll see some of that
in
the demonstration.
That's really powerful. Now obviously, it's simple to say we just click on this and it shows all the links. All of these links had to be manually created at the time of their creation, right? But you know what? That has to be done no matter what, whether it's in a tool or otherwise. So the fact that so it's not taking any more time, or even let's say it takes marginally more time to put it in a system versus writing it in a spreadsheet or something like that. The fact that you can come back,
you can analyze it, right? It's dynamic.
Huge.
The problem you see with doing it outside of tools, or doing it in Excel or doing it in other tools, is that data is, you did it once and it's static, and it's out of date as soon as you create that traceability manually. Mm-hmm. In a tool that doesn't support linked data and understands that, that we have this dynamic approach to it.
You know what it does? I think some people even don't understand the opportunity costs, because you've got, in order to manage static data, you've got to have highly trained engineers who are well versed in the system that in question, to go in and sort of mentally know all the places where this data is going to be linked, manually make these changes, right? And then hope that it's correct, and then hope that there's a little bit of time to actually do some engineering, because this is just busy work.
And that's the thing, is you're relying on tribal knowledge and expert engineers that are experts in their domain. But what happens if that engineer moves on? What if he retires? Where's all that knowledge go? Right? And RELM actually helps you with this, because
we used to be more morbid about it. I mean, we used to say, what if he gets hit by a bus, right? Or but better to say if they retire or something like that. Yeah. But sorry, I didn't mean to interrupt you. I did, but I'm sorry.
and we talked about where there's a whole ecosystem of data sources. So anything that follows OSLC standard, right, we're able to create this type of federated approach and utilize this concept of linked data, and that data can then be brought into RELM as a data source, and we can do these type of views with it. So let's actually jump into the demonstration.
All right, let's do it.
So here we're looking at RELM. We talked about the ability for RELM. It has 3 core capabilities, right? To be able to understand what data is there. So, it's got a quick search. I can just type in autonomous and let's see what shows up.
Mm-hmm.
Right, it's going to do a quick search. It's going to find some items. I actually want to go through and actually see everything related to autonomous, right? I can see that there's some project change requests, some specific requirements, but what if I'm only interested in test cases, right? I can apply that and I can filter down on those test cases. We have this ability to do things like start an analysis. So I can actually run through and say, you know what, I'm going to take this test case and I'm going to start an analysis because we're going to propose a change to it. We have things called profiles and filters that you can set up. I don't have anything set up here, so I'm just going to start a quick analysis, and it's going to compute all that data. So it's looking at
analysis. Oh, go ahead.
It's looking at all the elements that are utilized with that are associated to that test case. So it's going to look at all the links, all the attribute data, right? All types of data that's associated, and it's going to look at different traversal.
Could you make it a little smaller? I can't quite see the stuff at the bottom very well. I see the autonomous braking system test, and then I see a little, let's see. Nice.
So this can get
that's a little too small. Yeah.
Yeah. But just look at it. I mean, it can get quite lengthy and timing me out. Sorry, just gotta log back in. But you can just imagine that you can understand that one artifact can have multiple relationships to it. We're just looking at downstream, looking at 2 levels. Well, what if we look at both up and downstream? Right now, it's going to sit there and it's compute again, and it's going to look at everything again. Right now, it's going to be able to create that model and show that to you. So if you're going to say, listen, I want to know, I'm going to make a change to this. What other things do I need to consider? This is where we can apply filters, and we can kind of filter out some of the noise, right? Maybe I'm only concerned about the requirements that might be associated to it. Or maybe there's some automated test scripts that I want to understand, right? And so we can look at that and we can say, okay, here's this test case, right? We can see that it's running some test scripts. We can see that there's a related defect associated to it, right? So we can understand all that information. Mm-hmm. So that's just a quick way to do impact analysis.
At this point, you say, gosh, let's not change anything because it's linked to too many things.
Well, it's better to understand what it is linked to and not what it's linked to. And then you won't have an issue like you had over at one of those OEM suppliers with airbags, right? They didn't understand that something else was going to cause an issue with it. Better to find it out now than it is to find it out later.
Absolutely. Yeah, that's pretty powerful stuff. That's pretty powerful.
Yeah. And then finally, the other thing we can do is create these type of graphical traceability views. So we kind of showed some of this earlier in one of our previous sessions, but here's an example of how you can take, I have a feature, it's decomposed into system requirements. That system requirement might have some decomposed software requirements, and we can look at those software requirements and see, well, here are the test cases that are associated to them, and here are the results of them, right? And this is a dynamic view. So if I went and changed, so if an assessor comes in and says, well, you know what, I want to look at the speed control mode feature. Show me that you've actually implemented that, right? So I can select on it. I can see that we have the system requirements that are associated to that feature. We have the software requirements as we decomposed it. We have the associated test cases. And we can see that this thing ran, and we can color code these and say, you know what, it ran, and it's green because it passed.
Mm-hmm.
All right, so
looks like, and in this case, just to be clear, it looks like there haven't been test cases associated with speed control mode yet, and so that's something that you can easily see here that we need that needs to be done. Yeah.
Exactly. So you can help identify those gaps.
That's pretty neat stuff. Now, I noticed that this one's called the ASPICE Feature Coverage View, and we're talking in the context of ASPICE, but like we talked about before, I mean, this is a feature coverage view that could be used for just about any systems or software.
Exactly.
Project.
It really is. It's looking at some type of work item, right, and looking at the relationship between that work item. That work item is tracking these system requirements, right? Those system requirements are then being decomposed into software requirements. Mm-hmm. Those software requirements have some associated space. But you can create all different types of graphical views that you want.
Mm-hmm. And now, I mean, who uses this tool in particular? I mean, this isn't something that gets used by your software coders or whatever. This seems to me like it's your project or program manager or something like that, right? Somebody who's looking at the larger picture.
Exactly. Somebody who's got to prep for those audits. It can be software developers for doing impact analysis, right? But these graphical views are going to be more for somebody in the compliance area that wants to make sure that, all right, we've actually fulfilled everything that we needed.
Mm-hmm. And I assume, like most of the IBM tools, you can have different levels of access and editing rights and stuff like that. So you can give developers or engineers full access with no edit rights so that they can do impact views but not change things.
Just like our system, it's all role-based permissions, and you can set up those types of permissions who has the ability to do that.
Great. Anything else to show us regarding this, Amit?
No, that wraps up for today. I'm excited to talk to you more on the next topics.
Yeah. Hopefully, I'm sure we'll find something. Maybe not. I don't know if we'll need six podcasts to cover the whole theme, but if so, rock and roll. Let's do it. All right, so let's wrap up. Amit, the indestructible sword from IBM's Watson IoT, showing us the rational tools and how they can be used to both prepare for and to not prepare for an ASPICE audit, but also to use while using ASPICE as a process methodology on automotive programs, both at the OEM level and at the subcontract level, or the tier 1s, tier 2, I guess better said. And everyone, thank you for watching. We're going to wrap up here. This is 3-2-1 Gangs Change the Conversation. I'm Bryan Smith. And please, questions, comments, look below. There's links for more information. Subscribe. Check out our other podcasts regarding SAFe, the Scaled Agile Framework, and medical devices. And we hope to see you again soon at a future podcast. Take care.